Good afternoon, everyone. Welcome to the first session after lunch. Hope everyone's full, everyone's awake and ready to learn about some amazing free open source software. Today we've got Fukusuke Takahashi from NTT Data. Hope I got that okay. He and his team have written, well, to me it's famous, but maybe everyone doesn't know about it, but it's a fantastic Windows event log parsing tool, written in Rust, super fast, links to other great tools like Velociraptor and etc. So please make Fukusuke welcome.
Thank you so much. Thank you. Hello, everyone. Thanks for coming to my talk, Unveiling the Known Unknowns in Windows event log settings. I'm sorry for the confusing title, but at least I didn't call it Unveiling the Unknown Unknowns, which would just be a blank slide deck and me saying, I don't know. I was trying to say something to the effect of finding out the unknown things about your Windows event log settings, but ChatGPT turned the title into a kind of Zen koan, so hopefully you will be enlightened by this talk. Before I begin, I would just like to say that I'm not a native English speaker, so I apologize if any part is difficult to understand. This is the agenda. The first is fundamentals of Windows event logs. The second is the challenges in event log analysis. The third is solution with Hayabusa, Takajo, and Sigma. The fourth is issues with default event log settings. The fifth is solution with Weller and event log baseline guide and Hayabusa. Let me briefly introduce myself. I work in incident response as a member of NTT DataCert, the CSERT team of NTT Data Group company. I'm also involved in the development of open source DFIR tools with the members of Yamato Security, a Japanese cybersecurity community. I'll introduce each tool shortly, but to give you a quick overview, Hayabusa and Takajo are tools for analyzing Windows event logs. Weller is a tool for auditing Windows event log settings. The Suzaku is a recently released tool for a cloud log analysis. And I'm one of the developers contributing to these tools. Has anyone here ever used or heard of any of the Yamato security tools? If so, I'd really appreciate if you could raise your hand. Thank you so much. I'm glad to see some people are using Hayabusa. Thank you so much. Now let's move on to the main topic. First, I will begin with an explanation of fundamentals of Windows event log. The log files are stored in C Windows System 32 WinEVT logs. They are divided into more than 300 files, such as application EVTX, security EVTX, and in Microsoft proprietary binary encoded XML format. You can view the logs using the event viewer. However, the format is not very analysis friendly. For example, token elevation type is somewhat shown as a numeric value. The PIDs are displayed in hexadecimal, and some description are overly long. This is an illustration of how an event appears in XML format within the event viewer. In the XML content, the first part is enclosed in a system tag, which contains basic fields such as computer name, event ID, and channel. The second first is enclosed event date tag. Fields are variable depending on the type, non-human readable values, conversion needed, etc. Who wants to look at this data all day long during an incident? From here, I will explain the challenges in analyzing Windows event logs. 19 problems with Windows event logs for DFIR. At first, problems that only Microsoft can fix. Not an open format, so needed to be reverse engineered. The rendered message mapping is hidden away. Field values can be hard-coded in different languages. Rendered message can be very cryptic and confusing. And also, event IDs are not unique. Sometimes logging is on the target machine and sometimes on the source machine. Clearing logs and preventing logs from being written and forensics is easy. Certain events like log-off events don't get recorded 25% of the time. Field values can be missing randomly. For example, no source IP address on the logon type. Next, I will explain fixable problems with event logs. It is XML based, so 20 to 50% bigger than JSON, harder to parse, read, extremely noisy, maybe 70%. Fields as well as field names are variable and inconsistent. Sometimes multiple field name called data. Message either have too much explanation or not enough. Separated into 300 different files. Unreadable value, for example, %, 1432, and no mapping documentation. The labels are almost unusable for DFIR, like information, warning, error, etc. Conversion needed, for example, hex to decimal. Single events like a logon will result in multiple events logs, which you then need to correlate data. And most of all, an event viewer. Let's see if we can do better. Next, I will introduce open source tool that provide solution to these challenges we've discussed so far. Before diving into the tools, let me introduce the group behind their development, Yamato Security. Started in 2012, Yamato Security is a security community created by Mr. Doug Mattis, pictured at the top right, with the goal of building a cybersecurity community in Western Japan through free or nearly free workshops and events. He's an amazing individual and also the project leader for our open source tools. One point that is sometimes misunderstood, Yamato Security is not a company. It's a Japanese security study community run entirely by volunteer members. We have been releasing free and open source DFIR tools since 2021. This is a list of our open source tools developed by Yamato Security. All of these tools are publicly available on GitHub. We would be delighted if you give them a try. Now, I'll explain the analysis workflow using these tools. First, we start with EBTX files as input. Next, we use Hayabusa and Sigma to scan the EBTX files and process the output. The results are output in CSV or JSON format, which allows for easy automated processing with tools like Timeline Explorer or JQ. Finally, to simplify the analysis even further, you can feed Hayabusa's output into Takajiro to obtain a summarized analysis result. First, I will explain Hayabusa and Sigma, which are highlighted in the blue line. Hayabusa means peregrine falcon in Japanese and was chosen as peregrine falcon are the fastest animal in the world, great at hunting and highly trainable. Hayabusa is fast forensic timeline generator and a threat hunting tool. This diagram shows an overview of Hayabusa's DFIR timeline generation feature. It takes EVT-X files as input and output result in CSV, JSON, or HTML format, which are easy to process programmatically. During the output process, Hayabusa also performs various enrichment steps that are useful for DFIR analysis. Hayabusa supports Sigma rules, open source high quality detect the latest threat, over 4,000 rules. Only open source tool to support all Sigma version 2 field modifier and correlation rule to detect password guessing and brute force attack, etc. Added rules to detect more attacks and important events. Rules updated daily. The Hayabusa's goal is just to prove out the important events like finding needles in a haystack. This is the Hayabusa's flagship feature terminal output of CSV timeline. You can see the matched Sigma alert names and their levels along with the corresponding formatted event log entries and timestamps. The output is color coded based on the alert level. This is a timeline of event log frequency, which is generated the timeline creation process. As shown here, you can easily visualize the time series distribution of event counts. This is a summary of single rule detection result after scanning the EVT-X files. This is the HTML output result. Immediately see when an incident happened and a compromised host, a technique used. Now I run Hayabusa and show you the part I just explained in action. Today, we released new version for AUSCERT. So version 3.3.0 is AUSCERT release, and the release name is AUSCERT for the AUSCERT. Hayabusa has so many commands to analyze Windows event log. I will run CSV timeline command. This command creates a CSV formatted event log timeline. In this time, 498 EVT-X files will be scanned Sigma rules by Sigma rules. You can choose the rule level, this field. In this time, all events and I choose all events and alert rules and some options. Then now scanning 4,000 with 4,000 Sigma rules and 500 rules, and scanning is finished. As I said, detection frequency timeline. From here, you can get a virtual and you can get count between these timestamps. And also, you can get result summary grouping by alert level and alert date and alerted massing. For example, this critical alert, cobalt strike service instruction, is 6 times allotted. Also, this result can see in HTML format, right? So you can get result this kind of HTML formatted summary report. From here, you can see which machine is allotted and which sigma rules are detected from this report. And the created CSV is like this. Time column is timestamp column and sigma alert name, and details EVTX file fields. That is a flag sipped feature in Hayabusa CSV timeline command. Also, I will introduce some command. Extract base 60 command. This command, this command extract base 60 encoded string from EVTX file, and you can get original base 60 format string and decoded script or binary from this command. Yes. So let's move back to presentation. There are many other commands available as well. Due to time constraints, I won't be able to introduce all of them today, but I encourage you to take the README and try them out. Next, I will explain Takajo, a tool to analyze a result from Hayabusa. Takajo is a first forensic analyzer for Hayabusa's results written in NIM. Takajo means falconer in Japanese and was chosen as it analyzed Hayabusa's catches. This is a screenshot of Takajo's command line help. There are over 30 analysis commands available, maybe a bit too many. But don't worry, we have one command to run them all, auth magic. All you need to remember these two commands, Takajo auth magic and Takajo HTML server. Now I'll run some commands in Takajo to show you how it works. Before I run Takajo, Takajo's input file is Hayabusa's output result. So first, we have to run Hayabusa JSON timeline command, like similar to CSV timeline command. And JSON timeline command outputs a JSON format. Then create JSON formatted timeline in Hayabusa. Then Takajo uses this outputted result. Takajo, sorry. Also Takajo, today we released the Takajo new version and also to release new version 2.10.0. Run auth magic command. That's it. We can get various analysis results from one command auth magic, like extracting script blocks from PowerShell event logs and listing domains, hash and NRP, and starting like command line and computer IP address, logon and process, and creating timeline logon. This automatic command creates various analysis results by one command. You can see these results in case one file. Yes. For example, yes, timeline logon CSV. Yes. Sorry. Like this, you can check the only logo-related timeline from this CSV file, and for example, source IP and logon auth type and logon ID, like this. And another example, stack result. You can see the counted user from Hayabusa's result, like this. So let's move back to presentation. That is Takahashi's main feature. So far, I've introduced open source tools that simplify Windows event log analysis. From here, I'll explain the challenges with the default Windows event log settings. Big problems with default Windows event log settings. The first is the default log audit settings are terrible, and most of the logs you want for DFIR are not enabled. The maximum file size is 1 to 20 megabytes, so overwritten quickly. There are no tools to check Windows event log audit settings from perspective of DFIR. This is the output of audit poll, built-in Windows command used to check event log audit settings. As you can see, most categories are not audited by default. This is a screenshot showing the size of EVTX files using the PowerShell getWin event command. The size range from 1 to 20 megabytes, so they are quickly overwritten. Also, there are no tools to check Windows event log audit settings from perspective of DFIR. Let's see if we can do better. Now, I will explain the solution to the challenges we discussed earlier. The solution with an event log baseline guide and Vela and Hayabusa. First, I'd like to introduce a new tool released today, the event log baseline guide. Event log baseline guide's feature is visualize key area for improving settings. Compare measure event log audit settings guide like Yamato Security and an ISD or Microsoft. It gives you detailed reports on your settings from our security-driven approach based on Sigma rules. Also, daily checks based on the latest Sigma rules automatically updated via GitHub Actions. Let's take a look at event log baseline guide page. Yes, this is the guide for event log audit settings. You can choose which guide you want to check. So By default, Windows audit default setting is selected. The first table shows the Windows default audit settings, an audit category and a subcategory, and the rule count indicate the Sigma rule count in this categories field. And default setting enabled or disabled, you can check this field. And you can sort by value like this. The next table shows the default log event log size. For example, application in VTX is the default maximum file size is 20 megabytes. And the security SMB client security VTX file is 8 megabyte like this. The next section is statics on usable and unusable Sigma rules. The left part is usable rules in this Windows event audit log settings. The right part is unusable rule group, rule count. So if you set Windows default event log audit setting, you can only usable 600 rules, but on the other hand, unusable rule exists 1,800 rules. That is most worst point in Windows default audit settings. Also, next part is usable Sigma rules list allowed name and unusable Sigma allowed name list. And last part is usable rule group by audit category and unusable group by audit category, like this. Then, if you check another guide, select another guide, so automatically recheck and display the result. For example, Australian Signals Director's recommended guide is usable rules become much bigger and bigger compared to Windows audit default settings. Yes, let's move back to presentation. From here, let's use this guide to take a closer look at the challenges in the default Windows event log settings. Information about the log size can be found in the log file size setting table. As you can see, the maximum size are set between 1 and 20 megabytes. This table shows whether each audit setting is enabled or disabled by default, and how many Sigma rules are associated with each audit category. The grayed out rows indicate audit items that are unfortunately disabled by default. For example, the first row, process creation has 1,305 Sigma rules. However, since the logs required for these detections are not saved by default, the rules become unusable. This is a graph showing the number of unusable rules by subcategory. Detection rules related process creation and registry unfortunately do not record logs under the default audit setting. As a result, all such rules become unusable. In this way, understanding what cannot be detected under the default setting is what we refer to as the known unknowns. But how should we improve this? Today, we've released a new tool to help address these issues. It's called VELA. VELA's overview works on PowerShell and created by PowerShell. An audit Windows event log settings. Identify issues in default configuration, short log retention, weak audit policies. Provides actionable recommendation and visualize detection gaps using Sigma rule coverage. This is a screenshot of VLR's audit setting command. It visualizes areas for improvement in event log audit settings in various formats. This is a screenshot of VLR's audit file size command. This command simply and clearly shows the current maximum log size and the recommended setting in the visual format. This isn't VLR, but back to Hayabusa. Hayabusa also has a useful command for improving log settings called log metrics. This command outputs a list showing the first and last timestamp of each EVTX files along with the current size. It serves as a good indicator of how frequently each EVTX files is being rotated. Yes, today's last demo. There is a simple PowerShell, so you can learn simply from PowerShell terminal. Then audit settings. Sorry, break audit. Yes. You can check current log settings like this, and also you can check from GUI and filter like this. The last audit file size simply indicates a current EVTX file size and a maximum file size and default size and a recommended size. The last demo is Hayabusa's, back to Hayabusa's command and log metrics. Sorry. This command scan all EVTX files and output this table. And this table shows the, for example, system operation EVTX contains the first time is here, last time is like here, and this size is 762 megabytes. So we can check the current log state and when this EVTX file is rotated. Go back to presentation. Lastly, I'd like to introduce Yamato Security's event log configuration guide for DFIR and threat hunting. Yamato Security's guide for DFIR and threat hunting is a lot of documentation to learn about the different log settings and what attacks you can detect. We also published a batch file on GitHub called Yamato Security Configure Win Event Log Bat to help you easily improve your settings. Feel free to customize and use it for your environment. This is a screenshot of a section from the Yamato Security's guide. Finally, here's a summary of the log configuration improvement process using the tools introduced so far. The process for improving Windows event log audit settings consists of the following 4 steps. The first is understand default settings weakness using by event log baseline guide. The second is assessing the current state using Weller and Hayabusa's log metrics command. The third is extending log rotation using Yamato Security Configure Win Event Logs batch. And fourth is optimizing audit policy, also using Win Event Log bat. With that, I'd like to conclude this presentation by sharing the key message I hope to convey. The somewhat confusing title, Unveiling the Known Unknown, ultimately means unveiling the gaps in detection. In incident response, we often find ourselves investigating machines with default Windows event log settings. It's important to keep in mind that there are detection gaps, there are unknowns caused by these default Windows event log settings. It is equally important to reduce the unknowns as much as possible by improving Windows event log configuration to better prepare for the future incident. I'd be glad if you could take away both the key point and the slightly confusing title from this presentation. Thank you for listening.
Thank you, Fukusuke. We have a little gift from AUSCERT for you to take back. I hope you've got room in your bag. Fukusuke is here tomorrow, and he's flying back to Tokyo on Saturday. Have a look at the tool. If you've got time, you can actually, if you don't have Windows event logs handy, you can download them from the GitHub repo and try it out. So make the most of it. Thanks again.
Thank you so much. Thank you so much.